Today, the topic of my discussion is momentum. So, first of all, what is momentum here? So, I write a momentum. Here is the simple definition of momentum. So, the momentum is basically a product of mass and velocity of a body. Product of mass and velocity of a body is called momentum. Okay, is called momentum. And if we are talking about the mathematical form of momentum, so what is the mathematical form? Mathematically, we write momentum as a product of mass and velocity, right? So momentum is denoted by P, so it is equal to m into v. V is a velocity, and that's why momentum is a velocity. So when we discuss any quantity in a physics like a momentum, velocity, or any other quantity like acceleration, so we are discussing the characteristic of that quantity. So what are the characteristic of momentum? Characteristic basically describe this quantity is a vector or a scalar. So first of all, momentum is a vector quantity. Okay, momentum is a vector quantity. And secondly, the SI unit of momentum, SI unit of momentum is, what is SI unit? The unit of mass is a kg. So the SI unit of momentum is kg, and the unit of velocity is a meter per second. So it will be a kg meter per second. This is SI unit of momentum, kg meter per second. Okay, and the third one is direction of momentum. What is the direction of momentum? So momentum, the direction of momentum is according to the direction of velocity. Okay, direction of momentum is along the direction of velocity. Okay, direction of velocity. So if velocity is in opposite direction, so the momentum will also be a negative. The main thing, what is momentum in a physical situation? So when we are discussing with a layman person, so what is momentum? So note down this point as well. Momentum determines how easy to stop a light body and how difficult to stop a heavy body. So momentum basically, momentum determines determines how easy to stop a light body and how difficult to stop a heavy body. Okay, a heavy body. You know, a light body has a light mass. So momentum basically depends on a mass. So if a light body, we requires a less force to stop a light body, and for a heavy body we require a huge force to stop a heavy body. Momentum describes a moving inertia, means if your mass is in motion, this quantity determines the momentum. Okay, now the second point is we are discussing momentum and Newton's second law. Means momentum and Newton's second law of motion. Momentum and Newton's second law of motion. So what is Newton's second law in terms of momentum? So let us consider a body. Consider a body of mass m. Okay, mass m moving with velocity vi. This is the initial velocity of a body. Okay, if we apply a force, if we apply a force, the velocity of body change to vf, means force basically change the velocity of a body. Okay, the velocity of body change to vf. When the velocity is changed, it means acceleration is produced here. So acceleration is produced. So what is acceleration? Acceleration is a rate of change of velocity. So this acceleration is a is equal to vf minus vi over delta t. Okay, acceleration is a rate of change of velocity. So this is, let's say this is equation number 1. According to Newton's second law, what is Newton's second law? Newton's second law basically F is equal to ma, right? F is equal to ma. And if we are substituting the value of a in equation number 2, so just substitute the value. Substitute the value of a in equation 2. So what we get here? Just substitute the value of a in equation number 2. So the equation 2 become f is equal to m, and value of a is vf minus vi over delta t. And if you multiply m with vf and vi, so you will get mvf minus mvi over delta t. What is mvf? mvf is a final momentum. Okay, so we write it's a pf, and mvi is a initial momentum, so we write it's a pi. So pf minus pi over delta t. So what you get here? You will get a delta p over delta t. This is a Newton's second law in terms of momentum, means a force F is equal to rate of change of momentum. Rate of change of momentum. Okay, F is equal to delta P over delta T, meaning that the rate of change of momentum. What does it mean? Rate of change of momentum. So rate of change of momentum is equal to applied force. Okay,